Welcome to today's deep dive, where we're taking you on a journey into the hidden engineering beneath our cities. You and we walk over these structures every single day without a second thought. But the choices engineers make below ground dictate the timeline, the cost, and even the carbon footprint of the various cities we live in above. Historically, engineers used steel sheet piles temporarily. Solution A: they would drive them into the ground, build the concrete wall inside, and then pull the steel out. So it was just a temporary shield. Or they would do solution B, where they leave the steel in the ground as sacrificial, lost formwork, just burying it permanently behind the new concrete wall. But the modern approach, solution C, completely eliminates the concrete. That translates to a higher amount of usable square footage. And in commercial real estate, usable square footage is a metric that matters. That extra space means wider driving lanes, better turning radiuses, or simply more parking spots, which obviously drives revenue for the life of the building. So visualize these sleek, space-saving steel walls. But now we have to talk about how they're actually built. The traditional method of building underground is called open pit excavation. You install the steel sheet piles to form a giant rectangular box, dig out all the soil inside until you reach your target depth, pour your foundation, and then just build the car park level by level back up to the surface. The second method is where the engineering gets more sophisticated, the top-down excavation method. In this approach, you drive your steel retaining walls into the soil, but you do not dig a massive deep hole right away. Then you might wonder, how do you get underground? Well, you only excavate a shallow layer of surface soil, and then you immediately pour the heavy concrete for the ground-level floor slab of the car park. So you're basically building the roof of the basement just before digging the basement. Construction crews above ground can begin building the actual superstructure upward. You are burrowing underneath the structure, while the surface level above remains entirely active. That completely flips how we think about construction. Building upward and downward at the exact same time reduce the project timeline. But the crucial detail that makes this top-down method work is that these steel sheet piles are doing double duty, meaning they're doing more than just being a wall. They are not simply retaining walls holding back the lateral pressure of the soil. They simultaneously act as the primary foundational support for the entire structure. They're acting as the actual foundation. This requires a highly specialized load transfer method. When you have heavy concrete structures resting on relatively thin steel walls, you have to transfer that vertical weight safely. If you don't distribute it well, sheet piles could punch through the concrete cap. To manage these immense loads, engineers use highly specialized techniques. One of them is the knife edge support. It's calculated using specialized software called V-Load, which calculates exactly how to design these concrete caps and the reinforcing rebar cages inside them. So you literally just drop a rebar cage right over the top edge of the steel wall, pour the concrete into the mould, and the load is perfectly transferred down the axis of the steel sheet pile. No welding on job site, it's simple. So to bring all of these mechanics together for you, interlocking steel panels, cleanly driven into the soil with low noise and low vibrations, they are proving to be up to 40% cheaper than concrete walls. They can be welded completely tight against groundwater, and because they are made from metallic scrap in an electric arc furnace, they reduce the carbon footprint of heavy urban development by up to 80% compared to steel produced in a blast furnace. You'll never look at a parking garage the same way again. Thanks for joining us on this deep dive. Until next time.